Okay, so proceed to the next part. So this is for the exercise 2. I don't know if you heard about the Fibonacci sequence. So in this sequence, the first two numbers are set for you. So 0 and 1. And the next number is supposed to be the sum of the previous two numbers. So for the third Fibonacci number, it would be 0 plus 1. The fourth one would be 1 plus 1, right? The previous two. And the third one should be previous to 1 plus 2. So on and so forth. Okay, so there are many examples we see in the natural world. So I'm not going into detail. So this is like for you to work on as an example. So this is showing you the example of the Fibonacci sequence. So if you see this, there is 1, 2, 3, 5, 8. So the yellow boxes in here. Sometimes you see this in some of the biosphere, the biology world. Okay. So the first two numbers, they are set for you, so you don't have to calculate that. 0 and 1, the green box. And third one is 1, right? So on and so forth. So if n is an integer larger than or equal to 2, which means F2, right? For the first Fibonacci number, we call this F0, and then F1, and so on and so forth. So Fn will have an equation for that. It's the previous two sequence, right? It's two numbers, n minus 1 and n minus 2. So for example, F2 will be equal to F0 plus F1. So the previous two numbers. Okay, so this is what we see in the math, right? So what about the actual coding? Okay, so the first two rows, remember that they are given, so we don't have to calculate that. So the columns here are supposed to be telling you different parts of this calculation, right? First iteration, second iteration, we don't have to do them because they're given. So F0, the value for F0 is 0, value for F1 is 1. And then you will start to do the iteration in the third one in here. So for the third one, of course, is F0 plus F1, okay? And for the value of F3, F1 plus F2. So here you are doing a simple addition in your loop. And then you substitute the value, the result of this to Fn. Okay, for the third iteration, okay, let's say if you have two variables that you need and add them together, right? The previous two we're using Fa and Fb to represent them. So Fa, previous two, substitute F0 to Fa, substitute F1 to Fb, so that you have the numbers at your hands, right? Fa and Fb, which is the previous two values, and you just put them together and then substitute that value to F2. F2 is the third iteration. So this slide is talking about the third iteration only. Okay. So Fa, we have value F0, Fb, we have value F1. So why are we doing this? Because you have to generalize your equation so that when you loop over that, it will be the same phase. Okay, it would give you the same coding, right? So Fa plus Fb. This table is supposed to make it simpler, right? You have the Fibonacci sequence on the top, and then Fa and Fb. Add them together, and then you will have your current Fibonacci number F2, right? Previous two number and then F2. Okay, now we are done, right? We are done. We have calculated for the third row in here, which is F2, right? You substitute that to Fn. What would be the next step? We loop over to the fourth iteration. So for the fourth iteration, you're sliding this over, right? Start sliding this over because you need the previous two numbers. What would be the previous two numbers? So your current Fa and Fb on the bottom here, what would be the Fa and Fb? the FA would be the previous FB, right? You have slide one location to the right, right? Your loop is looping, is moving one step forward, right? So that's why you need to substitute this FB to FA first, right? And what would be your FB? FB would be the previous calculated Fibonacci number, right? So you substitute this Fn to FB. So here, these two substitution. And then you add them together. And that will be your F3. Okay, so now we have generalized the whole thing. So every time when you loop over, you just need to substitute this FB to FA and Fn to FB so that you have moved one step forward. Remember, this line is for your previous iteration, is for the third iteration, right? This line is for the third iteration. The bottom FA and FB is for your current iteration. So I've shown you in here with the arrows, right? So your FB substitute to FA, your Fibonacci number in the previous iteration substitute to F2, right? Now it becomes your previous number. It's no longer your current Fibonacci number, right? So that's why you do the substitution for these two lines, okay? And then you calculate your current Fibonacci numbers, which is F3 now, okay, F3 now. Okay, for the fifth one, you still do the same, right? You're sliding this one step forward. So FB substitute to FA, Fn substitute to FB, right? So on and so forth, which means that you can write the same line, same statement, and then you can loop as many times as you want, depending on what you put in your for statement. Okay, so this is for your non-coding exercise. I think, so this table is supposed to help you to write the coding in the next slide. Okay, you will have to fill in the blanks in this 2C exercise. So first do the 2B exercise. Okay, I think I'll give you some time to work on it. Okay. Okay, let's continue. I think most of you are done. So next part, we are working on so-called integration, right? So the real integration or the analytical form, for example, for this integration, right? There's a curve minus x squared plus 4. So for example, if this is the equation that you want to work on, and you want to find out the area under the curve between x equals to -2 and 2. So x equals to -2 and 2, right? So it would be the shaded area in here. So the proper way is to work on this, right? The hardcore math. But here, because this is a computational course, we are using your computational power to calculate this. So it turns out that there's no way to do this in a computer. All we can do is to chop the area down under this curve into different pieces. So in this slide, the example is that we just use the area for the triangles to try to use it as the approximation for the area under the curve, because we have the equation for this, right? Just simple operation, okay? Your computer can only do that. So if we do that, we know that the area for each of these triangles are 4. And 4 times 2 is 8. So you know that there is a great percentage of error if you use this. So then you want to be more accurate in calculating the area under the curve. So we separate them into 4 pieces. And each of them will have the same delta x. So the delta x is 1, right? If you do this, you will reduce the percentage of error a lot, which means that you can work on the area under the curve in this way, chop them down into even smaller pieces to get to a smaller percentage of error, right? We calculate the difference between these two. So this is for the case. Why am I showing you this? Because we have analytical solution for this, right? For area under the curve. If you don't understand integration, it's fine. So just know that the model answer for area under the curve will be 32/3. And we're trying to use our computer to reach that as close as possible. So here, the example is that we chop them down into 4 pieces and add them together. It would be 10. Percentage of error would be 6.3%, so greatly reduced. So exercise 3 is to calculate this. So this is a graph for the equation, and you are given the equation to calculate the area for each of them, for each of the shapes in here. So the area or the trapezoid area equals to A plus B times H. So H is the delta X, right? Delta X is 1 divided by 2. Okay, if delta X is 1, which means H is 1 in your equation for all the shapes. And A and B, what would be the A and B, right? The area under the curve all the way down to Y equals to 0. So it would be your values of Y, right? The distance for A, here it's 0. The distance, the value for B for the first box will be 1, 2, and 3, right? So exactly Y equals to 3 here. So we can have generalized mathematical representation each or every time when you work on each of these shapes. So here we have 5 values of X and Y. 1, 2, 3, 4, 5, 5 points, right? Because we have separated them into 4 pieces. So you have 5 values for X and Y, but you only have 4 values for A, B, and H, because 5 points, 4 shapes, right? Four different shapes in here. So 4 different shapes. So fill in the number, the value for Y. It's pretty easy, right? You have the value for X in here. You don't even have to calculate that, right? You just have to look at the graph. So the first 2, I've given that to you. 0 here, 3, which is the second Y value. What is the third Y value? Is 4, 3, and 0 again. So fill in the numbers, and then you calculate the area for each of these pieces, right? For the first iteration, A is 0, B is 3. For the second iteration, A is 3, B is 4. Okay, so on and so forth. H is always 1 because the delta X is. So if you look at this, compare the shape here, A, H, and B. Compare each shapes in here. You'll know what A is and B is and H is. H is always 1. Okay, and you will be able to calculate the area. The first one, I've given that to you, 1.5. So if you go back 1 slide or 2 slides, so these are the results. These should be the results in your table, right? 1.5, 3.5, 3.5, and 1.5. For the area on slide 26, okay. So you already have the answer. So everything is pretty easy. Okay. I think some of you have even done this already. So this one is for you to understand more about generalizing the whole thing. Maybe I'll give you some time to work on this first, right? Or most of you have done it. Okay. So if you look at this table, this is like a generalization of the equation, right? You substitute the equation what would be the x value? X value is just substitute x0 in here, right? And it would be equal to y0. And next, substitute x1 and use x1 and substitute, calculate the value for y1 and so on and so forth. And here, a and b is 0 and 3, right? So it's represented by the first y value and second y value. Okay, I think I'll give you some time to work on exercise 3. Okay. Okay, for exercise 3C, I have already listed the numbers for you here that you need. The x values -2, -1, 0, 1, and 2. So try to produce that with the functions that you have learned. Also for y. So I will make use of the zeros like function that you have learned, right? You have produced x values, and then you will be trying to produce y with the same size as x, but producing 0 values. So the 0 likes. Here, you are making use of the size of x and starting from the value 0. So this is just for the for loop, the sequence in the for loop. So put SEQ in here, right? I guess you are okay with this. So we are printing these 3 values. So the white box in here. So we are printing the values. So for the first iteration, I equals to 0, right? 0, 1, 2, 3, 4. So they are from your sequence. And x equals to -2 and y equals to 0. So we're just talking about the points on the curve. Okay. So even if you're doing this in a discrete way, you are still, so these are discrete, right? You just have 5 values coming from the curve. You are still looking at the original equation, okay? I think you are still okay with this. So we are doing for 2 for loops here. Why? So for the first for loop, you are calculating the values of y first. And then for the second for loop, you are calculating the area. Okay. Very simple. So for the fourth one, probably the most difficult exercise that you will be doing. The hint here is to use the code in question 3, but use a representation of delta x. So now delta x is no longer 1, which means that you will have to rewrite this program. Right here, the step is 1. Try to make it make it as a variable, right? The delta x should not be 1. So the step in your range or linear space, or maybe not linear space, in your range function or a range function should not be 1 anymore. It should be stated by you, right? You should have delta x in your range function so that you can adjust that anytime you want, right? You adjust the delta x anytime you want, and then your range or a range function will do the job for you, right? It will produce the list of x that you want. Okay, let's say if you want the step to be 0.5, what do? The step would be 0.5. You will be producing -2, -1.5, -1, and -0.5, so on and so forth. Okay, so try to think of the x and y's that you need to produce first. Okay, because you're using a different delta x. So once you can make your delta x into a variable where you can adjust, then you have done all the things right here, all the variables, because it's changeable, right? You can change it anytime you want, right? So the hint here is to use question 3 code and then add delta x in your code. Do question 3 again. Okay. Okay. Try to print your x and y values to see if they're correct or not, to see if they lie on the curve or not. Okay. And then work on the for loops. So this is my own personal habit. When I write a part of the code, I check on the numbers to see if they're correct or not, and then move on. It would save you a lot of time. If you do the whole program at once, then you will have a lot of bugs. You don't know where to start, right? Okay,